Okay, a very warm welcome to all the aspirants that are currently being associated with us in this SCAP portal for online education. I am Dr.Abhinav Srivastava. As usual, we are here with some specific problem that these problems have been asked by our we can say beloved students and that aspires for some important examinations as well. So today topic is slightly a bit different because this question has been asked for statistical purpose or statistical observations. We can say we have a question on statistics and the aspirant has asked this question to solve from us with conceptually explanations. So not wasting much of time, just elaborating the question. What does the question is saying? Now we have just written the question. Not currently I have not provided any solution for that, but I will solve and provide a solution corresponding to that question. Okay. Question is the application of the chi-square test. The question is based on chi-square test hypothesis. We can say what is first thing to elaborate to you is that what is basically a chi-square or what is the purpose of this test. Basically, if you are seeing the thing, what is the question is that we begin with the question, because on the behalf of question we will explain why this how this question can be solved and what is the basic meaning of chi-square test in application, we can say, because we have to impart our theory to the application in each perspective. So we have to first elaborate the application, that why and in what circumstances this test has to be performed to obtain the desired conclusion. Okay. The question is saying, consider a sample of 200 persons. We have a sample of 200 persons have been collected with a particular disease. These 200 persons are affected with certain diseases, a single, we will talk about the single disease was selected. Out of these, 100 were given a drug. 100 persons have been given out of 200, out of this 200 sample, 100% were given a drug and others were not given that drug. The results are, this is a chart, this is, we can say, this is a tabular form. Sometimes we can say it as relational database also. We have a certain relational database for that outcome of that drug. Out of 200 people 100 has been given a drug and the others were not given that drug. That means out of 200, 100 were given the drug, means 100 have not given the drug. So the table is like that. Table is formed. This data has been available with us, cured and not cured by that drug. Out of this 200% and out of 100% on in which the drug has been implanted, we have 65 persons cured, okay, and 35% have not been cured. In spite of giving drug, 65 persons have been cured, 35% have not been cured in spite of giving drug, and those persons out of others have also have a quantity which quantity 100, because out of 200 persons we have 100 persons only here that has been not given the drug, and that from that no drug perspective, those persons who have not given the drug, cured will be 55 and not cured will be 45. This also sums up to be 100. Now if we take the row wise addition, it will come out sums up to 120. 65 plus 55, 120. If we have sums up the not cured persons, 35 plus 45 gives 80. Okay, this data has been provided with us and we have to check, that test whether the drug is efficient or not. And we have been asked that the test whether the drug is efficient or not. So in this type of problems where we have to check for a certain specific thing that this thing is optimal or not, we will perform the chi-square test. Basically in primary motive it is for lower sample data, we can say we have few sample attributes, and in case we have a very large distributed data, then we can also use chi-square test, but with certain other conditions met. Okay, we have certain other frequency distribution phenomena that are implicated within the chi-square test, and we will compute the large sample data set. We will arrive at a hypothesis that contains a large amount of data. Okay, so we will just take a simple question and we will try to solve it with the chi-square test. Now, why we have opted for chi-square test? Now you can easily see that this type of problem can be solved by the chi-square test. We basically deal with a hypothesis whether this drug is efficient or not. We have certain data has been given imparting the drug beneficiaries as well as non-beneficiaries, and we have to check whether we have to arrive at a solution that the drug is efficient or a particular thing is efficient or not. That simply means that the chi-square tests have been performed to make a hypothesis regarding a certain situation. So that's why I have written it. This is I have written certain points about the applications of chi-square test as a test of good fit. Good fit signifies whether this particular thing is a well-versed fit for the database or not, or well-versed fit for the given circumstances or not. And the second second application is as a test of dependence / independence. The formulation has been given here. This is the measure of correspondence between the theory and observation. It is chi-square. The measure of correspondence between the theory and the observation. What is expected to come and what is observed quantity. So that chi-square, this is called the chi-square. This is the symbol, Greek symbol is there. This is called chi-square. Okay. Then chi-square is equal to summation of observations means, what is the meaning of observed? Means observed frequencies. Now here the frequencies signify the number of times the data is coming. Okay. And the expectations, that is the expected frequencies. Okay. This is the expected frequencies. So we compute the difference and we have a square of that upon expected frequency. This is the basics of computation of chi-square. Now I have solved this problem for you. That in the previous section we have discussed the aspects of the question, that we have certain data given. The data have been given. You can easily see by yourself. This is the tabular form given, and from that table we have deduced that table. This is the table. That is the basic table after calculation of the expected frequencies. So we have to arrive from this table to that table for computation, for arriving to a hypothesis. So how can we arrive at the hypothesis? And the last time we have discussed that what is basically we will start with the treating a hypothesis, that is null hypothesis. Null hypothesis always depict we can say the worst part of the case, and in that case the null hypothesis H0, the null hypothesis is always noted by the H0. This is the worst case scenario. I have already told you this is a worst case scenario, that is no relationship exists between two variables. No relationship exists between the two variables. In case of null hypothesis, always the null hypothesis depict the worst case criteria. We have two things, cured and not cured, and we have to if we examine the relationship between these two variables, we have to align these two independent things so that whether they have any dependency or not. We have to examine that whether this has any dependency or not. We are testing with the help of this chi-square test. So whether these two independent variables lead towards our solution that the drug is curable or not, we will start with the hypothesis. This is called the null hypothesis. That is, null hypothesis H0 is a worst case scenario, and we always represent it, that is no relationship exists between two given variables. This is the null hypothesis. In spite of that, other hypothesis, this is the first hypothesis, null hypothesis. This is the alternate hypothesis. This is just opposite to that of null hypothesis. Says that a relationship exists that is they are dependent. That these two independent things are now dependent. So in which we start with always with the null hypothesis. We start with the null hypothesis and check if our chi-square variable, that is I have calculated here, this if say this chi-square variable, that this chi-square entity has come less than that of the tabular value of the chi-square at 5% level according to the given degree of freedom, then it will be null hypothesis will be accepted. It is written here, if calculated value of this chi-square is less than the tabular value. What is the tabular value? Tabular value will always be given in the question, either it is given in the appendices of the data set. So I have written in that from the tabular format. If you see that from tabular data, value of the chi-square at 5% level for 1 degree of freedom is 3.84. This has been provided. If I have in for 1 degree of freedom, the similar case, because we start with the H0, we will gather the expected cell frequencies, we deduct the expected cell frequencies from that, and then we compute the degree of freedom of the system also. There I have computed the degree of freedom of the system. You can easily see that the degree of freedom of the system, number of rows -1 into number of columns -1. This is a general formula for that. Since we have 2 rows and 2 columns in our data set, we have 2 rows and 2 columns. So we have to compute the chi-square value at 5% level for this degree of freedom. For 1 degree of freedom, similarly chi-square value for 0.5 degree of freedom and for any other degree of freedom is an variation that has been provided to you, or appendices have been given to you that you can relate it from that appendix or from that table. So if the value of we have to compute the chi-square. If the value of the computed chi-square is less than the tabulated value, then our null hypothesis has been accepted. Otherwise, the alternate hypothesis has been accepted. That is, if the value of here, if I computed this value, that comes 2.084, and that is the less than the tabular data that is given. That is tabular data. What is it is provided? That is 3.84. So 2.084 that is arrived after computing the chi-square is less than this value 3.84. Hence our null hypothesis is accepted. This is our final result. So this has been the value of this chi-square at this degree of freedom at 5% is provided to you. You need not to compute that, but you have to compute your original chi-square value. Now the main thing, we started with the null hypothesis H0, and how we arrived to the compute our chi-square. The simple thing is, first I have taken it I have write it down in a step-by-step basis. You can see on the step-by-step basis I have been provided. We have H0. First step, H0, take the assumptions that drug is not effective in curing the disease, because our null hypothesis there says that no relationship exists between the two variables. So I have since the no relationship exists between the two variables, so we have taken our hypothesis as not null hypothesis, that take the assumption that drug is not effective in curing the disease. This is our H0 null hypothesis, and we have to compute by this hypothesis. Now second point is compute the expected cell frequencies. How we will compute the expected cell frequencies? You can easily see that if you see our given data, the expected cell frequencies signifies the probability of occurrence of two independent events. So probability of occurrence of two independent events events signify here that whether these events are occurring on we can say on independent basis, and how one independent frequency implicate over the other frequency or affect the other frequency. This is the expected concept of the expected cell frequencies, and we have to compute this we can say expected cell frequencies to compute our E value. E value, what I am actually in the computation of the chi-square test, we have difference between the observed value and the expected value. How will we compute the expected value? To compute the expected value, we have a simple formula that for each observed value we have row total into column total by grand total. This is the solo formula for the computation of the expected cell frequencies. This is the expected outcome. This is the observed, the table has been given the observed outcome, and we have to compute the expected outcome. This is the expected outcome. So how will you compute this expected outcome? This has been computed by the help of this formula, row total into column total by grand total. Now for each observed frequency, we have to compute the expected frequency. This is our observed frequency given, and we have to compute the expected frequency. How we will compute the expected frequency? For 65, this is row 1. What is the total net total of the row? That is 120 into column total. Its column total, that is 100, by grand total, that is 200. 200 samples have been given. This will give the expected self frequency for row 1 column 1. Similarly, the expected frequency for row 1 column 2, that is the row total 1 into column total of column second upon total grand total, that is 200. That is 120, that is row 1 into C2. C2 is the 100 C2 upon net total 200. So by examining this table, I have easily to sort out the things. I have computed the 4 expected frequency in a likely manner, so that you can compare and compute by your own. The simple formula for E11, E12, E21 and T22. I have written the written the subscripts also, so that you can easily identify what is R1, what is C1, what is R2, what is C2. This is R1. If I tilt the camera by this side, this is R1, this is R2, this is C1. I think C1 have a confusion. Look. Okay, see, I have inserted it. This is C1, that is C2, and we compute the expected frequencies there. And for each expected frequency, I have a tabled the data and subsequently written in that form. You can easily see. For 65, we have E11 arrived at by this calculation. This is arriving to 60. This is arriving to 60 also. This is arriving to 40, and this is also arriving to 40. Okay, these data have been written. Okay, so for subsequent, for E11, for O11, we have computed E11. This is written E11. That is E. I can say it is written E21. Okay, this is written E12, and this is written E22. Okay, so that thing is written, and I'm just checking that whether it is I have corrected right or not. That is fine. So for each observed frequency, expected frequency has been computed by this methodology. Each outcome has been given. We simply perform the O minus E, then O minus E square, then O minus E square by E. We compute for all the rows we have computed this, and we have added this. This comes to 2.084. You can write it down. You can compute it by your own in a copy. Then we have a simple formula for degree of freedom calculation. We have done degree of freedom calculation as number of rows minus 1 to number of columns minus 1. Since it is a 2 by 2, data have been given in a 2 by 2 tabular form. There is number of rows will be 2. These 2 rows and these 2 rows and these 2 columns. So number of rows and columns are 2 minus 1 to 2 minus 1. That gives the value. If you see here, then this 2 minus 1 is the value 1. 2 minus 1 into multiplied by 2 minus 1, that is the value 1. And in that case, we have computed for 1 degree of freedom, tabular data of chi square gives the value 3.84. The chi square at 0.5, we can say like that, 3.84. Okay, this can be written in this form. Actually, this will give you a summation that this is the nomenclature for writing the chi square value. This is 0.05 signifies at 5% level. At 5% level and 1 degree of freedom, the value of chi square, this is a tabulated value. That is the tabulated value. This is given the tabular form in the either provided in the index, or you can be given a data sheet for chi square. So okay, this tabulated form, this is the value. We have to compare our calculated value with this value. That is what we arrived at by calculating the chi square value of chi square. This is the value of chi square. We compare it with this tabulated value. If the value comes, this calculated value comes less than this value, the null hypothesis is accepted. Otherwise, alternate hypothesis is accepted. So if we compare this, we are seeing that this arrived value of the chi square, this is the computed value. You can say computed value of the chi square. We can say the computed value of the chi square is less than this value, because 2.084. I have written this, I think. Okay, I have already written this. Here the X calculator or computer value is 2.084. That comes less than 3.84. Hence the H0 is accepted. H0 means the null hypothesis is accepted. And null hypothesis says that drug is not effective at all. This how we will arrive at this solution is a very important point of concern. And I think if you are seeing this video, you are in a position that you may think that this technique is a very difficult technique, but believe me, this is not a very tough technique, but a systematic scenario. If you follow systematic procedural thing, you can follow the steps. First deduce for H0, and then deduce the effective cell frequencies E, expected cell frequencies we can say. Then made a table like that. This table has been formulated for expected cell frequencies, and after the computation of that, see the value of the chi-square in the tabular form for the degree of freedom arrived. Compare the value of the chi-square that is calculated, and if the value of chi-square computed is less than the value in the tabular form, then the null hypothesis is accepted. Otherwise, the alternate hypothesis is acceptable. So this is the thing. This is not a very complex thing, but you have to formulate for expected cell frequencies. Better, it is always the better option to write in the original content the value of E11, E12, E21 and T2. It is a 2x2 thing. If you have 3x3 or 4x4, the same similar procedure have been adopted, and you arrive to a hypothesis that whether we can say a conclusion that whether the thing is going in the null hypothesis way or alternate hypothesis way. Okay, thanks for watching this video, and keep on repeating this video, keep on repeating this video if any doubt prevails, and we are always open to curtail your doubts by various means, either on my mail or WhatsApp. Okay, so I think that's all for today. Thank you for